Hi everyone, my name is Ahmad Pratama from Stony Brook University. I am the university library's data literacies lead. And for this CNI project briefing, I'll be talking about the accuracy bias trade-offs in AI text detection tools and their impact on fairness in scholarly publication. Here, I'll explain why these tools matter, how I evaluated them, what I found, and where I see things going next. First, let's ground ourselves. AI text detectors are tools that claim to identify whether texts are human written or AI generated with a very high accuracy, up to 99%. They are often marketed for academic integrity checks, plagiarism detection, and ensuring transparency in writing. It's been widely recorded in the recent literature that researchers increasingly use ChatGPT, Gemini, and other LLMs to draft, edit, and polish their manuscripts. This widespread adoption, however, raises some ethical concerns, especially in terms of authorships and transparency. Some papers have been retracted due to undisclosed use of LLMs in the published article. In response, AI text detectors promise to protect integrity, but how well do they really work? As we all know, English is the international language of scholarly publication. All reputable journals require that manuscripts conform to elevated linguistic standards, often necessitating professional proofreading services that can be prohibitively expensive. This has put non-native English researchers at a disadvantage due to significant challenges in navigating the scholarly publication realm. And given both the LLMs and the AI text detection tools are heavily trained on English datasets, it may unfairly penalize non-native authors. There is also another issue about different writing styles across disciplines that may further complicate AI text detection's process. Because of that, my study focuses on three key questions. First one is accuracy. How well do detectors identify human written, AI generated, and AI assisted text? Second one is bias. Is there a trade off between accuracy and bias in these detection tools? And the third one is fairness. Do certain groups of authors, especially non native English and those in certain fields, face disadvantages when their work are evaluated by these tools? To answer this, I ran two experiments. First scenario, I compare purely human written abstracts to purely AI generated ones. In other words, this scenario has a clear ground truth. In the next scenario, I analyzed AI assisted abstract, where I had the original human written abstract in the previous scenario refined by LLMs, creating blended text. For generations and enhancement by large language models, I use the two most advanced publicly available large language models at the time of the experiment in late December 2024, ChatGPT o1 and Gemini 2.0 Pro experimental. This way, my results reflect state-of-the-art capabilities of these large language models. I evaluated three top detectors, DetectGPT, GPTZero, and ZeroGPT, all freely accessible, with some offering premium options by subscriptions. These are representative of what researchers might actually use in real life. My dataset comprises 72 journal articles published by 2021 or pre-ChatGPT across three different domains. First one is technology and engineering, second one is social sciences, and the third one is interdisciplinary, each from three different journals. I balanced native versus non-native English authors to test fairness. So for authors affiliated with institutions in the five Anglosphere countries, which is Australia, Canada, New Zealand, United Kingdom, and United States, they were chosen to represent the native English speakers. As for the non-native English speakers, only authors affiliated with institutions from countries where English is neither the official language nor spoken by more than half of the populations were included. Any articles with multiple authors from both native and non-native categories were excluded. I used standardized prompts to generate both the AI-generated and AI-assisted abstracts. As you can see here, I ran the prompt once for each journal. So there are 9 journals, 2 types of abstracts, and 2 LLMs. So in total, I ran 36 times to get part of the dataset. To evaluate the results in scenario 1, I used 3 primary metrics. First one is accuracy or correct classification. Second one is false positive rate, where human written is flagged as AI, and then false negative rate, just the other way around, AI generated flagged as human written. Additionally, I used 2 dataset-wide metrics for the risk for human authors. The false one is false accusation rate, where is at least one false positive and majority false accusation rate, where there are more false positive than true negative. In scenario 2, where no clear labels exist, the focus shifted to quantitative analysis, evaluating the percentage scores provided by the tools. Here, I use summary statistics and some statistical tests across author status and disciplines, as well as 2 other metrics given the tendency of these tools making extreme classifications, either 0% or 100% AI. They are called under detection rate or UDR and over detection rate or ODR. And this is the results. So one detector, which is GPTZero, did reach around 97% accuracy overall. So still falls short of their claim of 99% accuracy. But the other two hovered around 55 to 65% only, and even dipping below 50% in some cases, which means they're no better than chance. This is alarming for integrity checks. And also, all 3 had better accuracy in the native English speaker category than the non-native English speaker ones. DetectGPT, in particular, had noticeably higher false positive rates for non-natives compared to natives. Again, another red flag. For the data set-wide metrics, the false accusation rate showed no difference between native and non-native authors. But the number is quite high, around 44%, almost half. And in terms of majority false accusation rate, it's quite small, less than 6% for the non-native authors, whereas for native authors, it's around 2%. But still, the number is quite alarming, considering that majority false accusation rate means there are more tools with false positive than the one with true negative for the exact same dataset that is originally human written. And in terms of disciplines, social sciences abstract had the lowest false accusation rate at 25%. But interdisciplinary abstract had more than double. It is the highest one at 62.5%. Even when the ground truth is clearly established, we can see how much inconsistency and unreliable these tools can be. And in real-world context, these days, texts often blend human-written text with AI-generated one, and this is where the results from the second scenario fill the gap. So, in scenario 2, as we can see from the density plots here, it shows mostly U-shaped patterns. These detectors, except for ZeroGPT in the middle, had a strong tendency to yield either 0% or 100% AI, with much fewer moderate scores in between. In many cases, authors who use AI to polish their texts that they originally wrote themselves end up labeled either entirely human or entirely AI, with little to no middle ground. The statistics with Welk's t-test confirms a clear bias against non-native authors by GPTZero, which, from the previous scenario, was the tool with the highest accuracy. This raises significant concerns about the unintended consequence of its use. And this is the distributions of scores by disciplines. Again, with the exception of ZeroGPT in the middle, we can see similar and even much more consistent U-shaped patterns here. A Welk's ANOVA test confirm the gap in detection scores across discipline, especially in tech and engineering abstract in ZeroGPT case. And this is the result for the extremes detection scores, 0% for UDR and 100% AI for ODR. Once again, the ODR gap between native and non-native authors in GPT-0 is very concerning. This pattern once again underscores the disproportionate risk faced by non-native English authors, who ironically are the ones most likely to benefit from using LLMs to improve their English writing. Yet, at the same time, they are also the most likely to have their contributions dismissed entirely by AI text detection tools. To summarize, this study exposed unreliable detection by these AI text detection tools. While all of them claim to be highly accurate, 99% accurate, the fact is none of them is 99% accurate. One reached 97%, but 2 out of 3 misclassified nearly, and sometimes even more than, half of text with clear ground truth, meaning they perform no better and sometimes even worse than random guessing. The results also show these tools suffered from inconsistent performance across disciplines. Different tools perform better and worse in different fields. This inconsistency adds more questions to the implications of the use of these tools, especially in academic settings. Then there is the issue with polarized scores on AI-assisted text, where instead of a bell curve shape, the detection scores mostly resemble U-shaped patterns. And finally, tools with higher accuracy does not mean it promotes fairness. In fact, they are suffering from severe bias against certain groups of authors, especially the non-native English speakers. As this study exposed, 1 out of 4 AI-assisted texts by non-native English authors were flagged to be fully AI-generated, far more often than 1 in 10 native English speakers. Based on these findings, I recommend 3 things. First, if we must use AI text detectors, use them as advisory tools. Don't ever let it be the judge, because the risk of false accusations is high, especially for the non-native English speakers. Second, instead of stigmatizing or even penalizing LLM use, let's embrace ethical and transparent AI tools adoptions instead. Focus on promoting responsible use with full transparency and author accountability. Finally, perhaps it's time to recognize AI assisted copy editing as the new norm. Even before LLMs emerged, many published papers underwent professional proofreading or copy editing without explicit acknowledgement in the final publication. Why should AI-driven copy editing be treated differently from human-based editing? At the end of the day, the ultimate responsibility for accuracy rests with the authors, not with the proofreaders or copy editors. Instead of asking authors whether they have used AI tools to polish their manuscript, we could simply require those who do not use AI to explicitly opt out through a no AI involvement declaration. That said, this is only for AI assisted editing. Any other forms of LLM involvement, such as generating text, images, or other content from scratch using a simple prompt, should be fully disclosed. Finally, the emphasis should remain on the substance of the research and the scientific rigor it reflects, rather than the tools used in its production. The study highlights the problems in relying on detections-based approach when it comes to AI-generated or AI-assisted text, but it also has some limitations. For example, the disciplinary scope of the selected journals was intentionally limited due to practical constraints, broadening it to other fields like natural sciences, humanities, health sciences, and professional fields like business, economics, medicine, or law can strengthen the generalizability of the findings. Also, the analysis focused on a limited number of popular and publicly available AI detection tools. Incorporating additional detection tools, especially those commonly used in higher educations like Turnitin, for example, can enhance the real-world applicability and relevance of the finding, especially in academic settings. Thank you for watching. You can scan the QR code to access my dataset and Python code on GitHub. At the time of recording, this research is currently under peer review. Any updates, including publication details, will be posted to the GitHub repository page linked by the QR code. Thank you again and have a good one.